Now let us look at an example recursive function for finding sum of first n natural number. So first of all, I'll explain you what does it mean by sum of first n natural number. Then I will devise a recursive function. Then we will write a recursive procedure, that is function, using C or C++ language. Let us understand what does it mean by sum of first n natural numbers. So if I take some natural numbers like 1, 2, 3, 4, 5, 6, 7. Suppose I want to take up to 7, then I want the sum of all these. Summation of first n natural number. So how many natural number? First 7. So first 7 means 1 to 7. Now same way, if I say first n natural numbers, then it is 1 plus 2 plus 3 plus 4 plus goes on to last term is n. N can be anything. Like in this previous example, it was 7. It can be anything. Now for this summation, let us write a recursive definition. So for recursive definition, I will say sum of n terms is 1 plus 2 plus 3 plus 4 plus goes on to. Now before nth term, there will be n minus 1, then n. So I have included one more second last term. I am showing it. Now, if I take the summation till here, this is nothing but sum of n terms is sum of, this is n minus 1 terms. See, n terms means 1 to n, then n minus term will be from 1 to n minus 1. Then 1 to n minus 1 will be from here to here, that is till this point. Then what more is remaining? Plus n. Then if I add n to that, it gives me up to n. So this became a recursive definition. Now this I can write it like this. Sum of n terms can be defined as sum of n minus 1 plus n if n is greater than 0. If n is equals to 0, then it's not a natural number. Natural number starts from 1 onward. So n is 0. So let us say answer is 0. See, remember, whenever you define any recurrence relation or recursive function, then you must have two type of statements. One is for the large value of n, what is the formula? Then for the small value of n, what is the answer? So usually for small value, we give a direct answer. So if n is equals to 0, there is no formula, direct value is there. So based on the same thing, I can write a recursive function in C or C++. Let us say int sum, which takes integer parameter n, and if n is equals to 0, return 0. Otherwise, return sum of n minus 1 plus n. So here what I want to explain you here is, if you have a recursive definition of any problem, then directly you can convert into a recursive function in any programming language which supports recursion. So in C, C++, you have recursion. So you can directly convert this one. See, if sum of n, and if n is equals to 0, return 0. If n is equals to 0, return 0. Otherwise, if n is greater than 0, then return sum of n minus 1 plus n. So sum of n minus 1 plus n. So that's it. That is a recursive function for finding sum of first n natural number. Now finally, I have one more thing to show you, that for finding the sum of first n natural number, there is a direct formula, that is n into n plus 1 by 2. So this is the formula. So it means I don't have to write a function for that one. Function will consume time and it's a recursive function, and it will take time for making number of calls. Instead of that, I can simply use a formula and write a program. So usually we write just a formula whenever we have to find out sum of first and natural number instead of writing a function. But for experiencing or learning recursive functions, I have taken this example. Even the same function, we can write it using iteration, that is using loop. Recursion will be costly because it uses stack internally. So I will write down two more versions of the same function. Instead of recursion, I will use loop, and also I will directly use the formula and show you. So I will remove this definition, then I will write down two more functions. Here I have a function for sum which is directly using the formula. If you pass the value n, then it will take the formula. Using the formula, it evaluates n into n plus 1 by 2 and returns the result. So this is the simplest function and it will take very less time. It is just constant time because just it has to evaluate a simple expression. So I can say that the time taken by this function will be constant. Few number of operations like 1 operation, 2 operation and 3 operations. So total it may be performing 3 operations, that is constant. So this is the fastest method. This is using formula. Now here I have a function for finding the sum of first and natural number using loop. Now this function, it takes the value of n and it will start I from 1 to n. So I will start the values from 1 to n. Initially s is 0, so this I value from 1 to n will be keep on added to that s. So first time 1 is added, the next time I becomes 2 and 2 is added, then 3 is added, then 4, up to n all numbers are added and this is returned. So this is using loop. I have written the function. If I find the time complexity of this function, so one of the major important statement is this one, and this statement is repeating for n times as I is taking the values from 1 to n. So this will be repeated for n times. This is statement one time only and this is statement one time. And if I consider for loop, mostly it is written as n plus 1 time. So the main statement is this one. So this is executing for n times. So I should say that the time taken by this algorithm is order of n. Time taken is order of n. I have found out the frequency of execution of each statement, and this the main statement is this one where the addition is done and that's going to execute for n time. So our focus is on that statement, this order of n time. And how much memory it takes? Just 3 variables are there, that is I, s and n, that is passed as parameter. Only 3 variables are there. But what about recursive function? A recursive function internally uses stack. Whatever the value of n we pass to that, it will make those many calls and it will create those many activation records. So it's having just one variable n, so that n variable will be created many times, as many times, depend on the value that we are passing. So it takes more space, but the time will be order of n only. So let me trace this function and show you for the value 5. If I call this function sum for value 5, then what it will do? If I pass 5, 5 is not 0, then it will call sum of n minus 1 plus n. So it will call itself for sum of 4 and the value of n is what? 5, that is added. So it's making one more call. Then in this call, again the same thing, it's not 0, so it will make a call for sum of 3 and then also add 4. Then it will make a call for sum of 2 and also add 3. Then sum of 1 and also add 2. Then sum of 0 and also add 1. Now finally sum of 0, as it is 0, it returns 0. So this is 0. So 0 plus 1 is 1 and this is returned here. So this is 1 plus 2, that is 3. So 3 is written here. So this is 3 plus 3, that is 6. 6 is written here. So 6 plus 4 is 10. 10 is written here. So 10 plus 5 is 15. 15 is written here. So the result is 15. So while returning, the addition is done and you can see that how many calls it has made. For 5, it has made total 6 calls. So the size of the stack is 6 and the variable n is created for 6 times. So memory is more. But how much time it is taking? There are total 6 calls. So for value of 5, there are 6 calls. So for value of n, there will be n plus 1 call. So it is order of n. So the time taken by this function is order of n. But space is also 6 times for the value of 5. So the space is also n plus 1. So space is also n plus 1 here. This is time. So there, recursion is costly, but it was easy for converting a mathematical definition, that is recursive definition, into a function. That's how recursions are easy to write compared to loops. For loop, we have to devise some logic, work on the problem, understand the problem, devise some logic. Then it may work faster. compared to recursion, and it takes less space compared to recursion. So mostly in our applications, in our program, we write loops only instead of using recursions. But actually the problems are solved using recursions in mathematics. So I have taken a very simple example and I have shown you how we can define a recursive function for finding sum of first and natural numbers. Now in the coming videos we'll see more examples of recursions.